All right, guys, we'll go ahead and get into our next section of notes for this unit here. And I'm actually going to change the date real quick. This is going to be on the 9th and 10th. So label for today is 6.2, SSS and SAS. Date today is either the 9th or 10th, depending on what class you have. And our objective for today is we're still continuing that goal that I talked about last time, which is we're trying to prove that triangles are congruent. And specifically, we have some theorems that we can now look for and be able to use basically as shortcuts so that I don't have to list all the pieces here. Okay, so first off, a little review. What does that mean for two shapes or two polygons to be congruent? Okay, so congruent polygons are this, like we said last time. They are two or more shapes whose corresponding sides and corresponding angles are all congruent to each other. So remember, this is basically our lesson from last time. We said we have to show all the pieces from one are congruent to all the pieces of the other. Without that, if something's missing, then I can't say that the shapes as a whole are congruent. Well, like we saw, our last example from last time, we had to just list out essentially 6 things, 3 sets of sides and 3 sets of angles. Okay, and that's a lot to list out, especially if we're going to start putting these in proofs. So what we do, or what we have, is these little shortcuts that can basically cut that in half. So this is what leads us to the SSS, or in other words, the side-side-side theorem. Okay, and the side-side-side theorem says this. It says if all 3 sides of one triangle, are congruent to all 3 sides of another triangle, okay, if this is the case, if all 3 from one are congruent to all 3 of another, then what I can say is I can come to this conclusion that the triangles as a whole are congruent. Now I'm just going to use the congruent symbol for this one to save on space. If all 3 sides of one triangle are congruent to all 3 sides of another triangle, then the triangles are congruent. Okay, so this is huge because, like I said, this basically just cut our workload in half. Usually we'd have to list all sets of sides and all sets of angles. Now we don't even need to worry about the angles if we just show the sides here. So I'm going to go ahead and show an example here. Let's say we have 2 triangles. Make them look roughly the same. And let's say we have the same thing as we've seen before. Keep it simple. We'll just be A, B, C, and D, E, F here. And what I'm looking for to prove this theorem or to match this theorem is all 3 sets of sides. So for example, we could have one pair of sides that are congruent, A, B, and D, E. Another pair of sides that are congruent, B, C, and E, F. And then last pair of sides, A, C, and D, F. And notice here on that last one, I'm marking that with 3 because that tells me that A, C, and D, F are congruent, but not necessarily any of the other ones that I've already marked. Okay? So this is our shortcut that we need to be looking for so I don't have to list out 6 pieces of information. And specifically, we're going to be using this a lot in proofs. So here's what I want you to do. I want you to sketch this diagram for me, and then don't worry about the given or the prove. We'll get to that once we start setting up our proof. Okay, so I have these 2 triangles here. They look a little bit different than what we usually see because they're not separated. And usually this is the case. You're going to have a diagram with 2 triangles right next to each other or attached somehow. And so what I want to do is I want to set up my 2-column proof. I know it's been a while since we've done some of these. So we need to kind of remind ourselves here, statements and reasons. And remember, no matter what proof we do in this class, no matter what we're talking about, the first reason is always going to be the same. The first reason is always going to be given. So I know I can have that one automatically. And then for the first statement, remember, all we need to do is copy down our given information. So we're not getting into anything just yet. We're not trying to rush through this. We're just trying to write down all of our information. We're told QR is congruent to SR, and then we're also told RT bisects QS. Okay? So here is how we're going to work through these proofs, because we're going to use the same strategy over and over and over again. And if you can get this strategy down, you'll be able to work through a lot of these here. So first off, a recommendation that I have is anytime that you list that angles or sides are congruent, I would go ahead and mark that in your diagram. So for example, our first given statement is that QR is congruent to SR. So I'm going to go ahead and mark that here. And notice our end goal is to prove that the triangles as a whole are congruent. If we want to do that, you need to ask yourself the same two questions on every single proof that we do in this unit. The same two questions over and over and over again. First question that you always need to ask yourself, what do I know from my given information? So if I look at this here, I notice I have one piece of given information. I'm told that those side lengths are congruent, and that's kind of already doing its job. It's got one pair of sides. Okay, now we need to look at other piece of given information. So the other piece of given information that I have is RT, this line right here, bisects this segment, okay, QS. And remember, if we see that word bisect, that means to cut into two equal halves. So if I take QS and I cut it into two halves, those two halves are going to be equal or congruent. So for instance, those two halves are going to be QT and ST. And so this is exactly what my next statement is going to be. I'm going to say QT is congruent to ST. Okay, that is my next statement. I ask myself, what did I know from my given? Well, since that is bisecting, that bisects it or cuts into two congruent segments. And what is my reason for that? Well, remember, we said it was a bisector, and specifically it's bisecting a segment. So simple enough, I can just say definition of segment bisector. Definition of segment bisector. Okay, so now I have another pair of sides that are congruent. So that is the first question I'd always ask. What do I know from my given information? Second question that you always need to ask on every single proof. What do I know from my diagram? What do I know from my diagram just by looking at it? Well, notice here, we have two pairs of sides that are congruent, and if we could just get the third pair of sides, then we could use that theorem that we just talked about. And by looking at this diagram, I see that third pair of sides here is the shared side. It's in both of the triangles. And that would be this side length RT here. And so what I'm going to do is I'm actually going to keep this very simple. I can say RT, referring to the side on this triangle, is congruent to itself, the RT in the other triangle. So simple enough, I can just say RT is congruent to RT. I can say this because it's in both of the triangles. If it was just in one of them, then this wouldn't really help us at all. But notice I've said this, and my reason for this is actually a property that we're going to use a lot this chapter, and it's something that we talked about last semester. It's essentially saying something is always going to be congruent to itself. We know that just as a fact, but we have to show that or explain that in a geometry way. And so this is what we call the reflexive property. Okay, and this would be a good idea to memorize this or get this down because, like I said, we're going to use it a lot. Okay, the reflexive property. Okay, always says that something's congruent to itself. I've answered those two questions here. What do I know from my given? What do I know from my diagram? And I will pretty much promise you that every time you answer those two questions, by that point, you'll usually have enough information to show that the triangles are congruent here. And in this case, I do know that they are congruent. This does match one of the theorems that we've talked about. So I can go ahead and jump to my final statement. I'm going to say triangle QRT is congruent to triangle SRT. Okay, the triangles as a whole are congruent. And how do I know that? Because I haven't listed anything about the angles. Well, I've matched one of the theorems that we talked about. We talked about the side theorem. All three sides from one triangle are congruent to all three sides of another triangle, so the triangles are congruent. Okay, so this is how we work through proofs in this unit. Okay? Another theorem that we have, another shortcut that we can use so I don't have to list 6 pieces of information, is what we call the SAS theorem. And you can kind of figure out what this stands for here using what we talked about. Okay, this is going to be the side angle side theorem. And the side angle side theorem says this. It says if two sides and what we call the included angle of one triangle, if two sides in the included angle of one triangle are congruent to two sides and the included angle of another triangle and we'll draw a picture with this as well. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then I can come to the same conclusion I always am going to, which is the triangles as a whole are congruent. So again, another shortcut that I have where I really only need 3 pieces of information as opposed to 6, and in this case we don't even need all 3 sides, we just need 2 of them and what we call the included angle. So for example here, if I want to draw a couple triangles here, let's draw this triangle, let's draw this triangle. So like it says, and I'll go ahead and label these as well, let's say JKL and MNO. Okay, like this theorem says, if I want to match this, what I'm looking for is I'm looking for 2 pairs of sides. So for instance, JK and MN is one pair, KL and NO is another. And then when we say the included angle, what it means is it's just like it's written out. We see 2 sides with the angle being in between them. Same idea up here, 2 sides with the angle that is in between them. So in this case, that would be angle K and angle N. Okay, this is the side angle side theorem. And that angle has to be in between the 2. If the angle is not in between those, then this theorem does not work and those triangles are not congruent. Okay, so keep that in mind. The angle always has to be in between the sides. Okay, so putting that to use here, how can we see that in a proof? Okay, example 2. Okay, we're given this in usually the same way, or usually it's more distinct than just written out. But take a sec and sketch this diagram for me here. And then once we have that sketched out, we'll go ahead and set up our proof. Okay, same as always, I have my statements and my reasons here. And I always know where I can start on these. First reason is always the same no matter what. It's always given. Given information here. And like I mentioned, usually it'll be more distinct. It'll say given, colon, and then it'll have a specific statement that you can just copy down. But here it's very similar. It's just given that, and then we have a statement. And so I'm just going to copy down that statement. R is the midpoint of QS and PT. I'm told R is the midpoint of QS and PT here. Okay? So, if I want to work through this proof, eventually we're going to do the same thing as always. We're proving that 2 triangles are congruent. You'll notice that is your proof statement pretty much every time. Okay? If I want to go through this proof, I need to ask myself the same 2 questions over and over and over again. First one, what do I know from my given information? Well, notice here I'm told R is the midpoint of a couple different lines. So I'm going to take that one at a time here. If I say R is the midpoint of that first line, QS, remember midpoint means halfway across. And so if something is a midpoint, that means the segments on either side of it are going to be the same length, or they're going to be congruent. So for example, these 2 segments here would be QR and SR. So I'm going to say my next statement is QR is congruent to SR. Okay? And I'm going to use the same idea before I write my reason. I can actually use the same idea because I'm also told R is the midpoint of the other line, PT here. And if that's the case, it's the same thing. If you have a midpoint, the sides on either end of it are going to be congruent. So for instance, right here, PR and TR. And notice again, I'm going to mark those with 2 dash marks because I want to say that they're congruent to each other, but not necessarily the other sides that I've already said. So PR is congruent to TR. Okay, and what is my reason for both those? Where did I get that information? I got that from the fact that R is the midpoint. And so this is what we call the midpoint theorem. If something is a midpoint, then the sides on either side of it are going to be congruent. Okay, so now this is good because I already have 2 pairs of sides, and now I just need one more piece of information. So I've answered the first question, what do I know, from my given information? Next thing I need to ask myself is what do I know from my diagram? Well, this one, it's not going to be the same as last time because I noticed I don't have a shared side, because otherwise we could always take that shared side and say that they're congruent to itself. But what I do have here, another thing that I can be looking for when I ask myself, what do I know from the diagram, is I see I have a pair of vertical angles here. Notice I have these two right here. So if I'm going to go to name this, I can't say angle R and angle R because that can mean two different things. I'm not saying that it's congruent to itself. So I need to list these with 3 letters that make up that angle as opposed to 1. So the first one here is going to be angle PRQ. Angle PRQ. Remember, when you're naming it with 3 letters, you want your middle letter to be the vertex. You want it to be where the angle kind of comes together. So I'm going to say angle PRQ, and then it's congruent to angle, and we need to be careful about how we go in the order of our letters, because a lot of you would probably want to say SRT. But notice that wouldn't match up with how we have it written up here in our proof statement. Okay, notice P is going to correspond to T, R to R, and then Q to S. So what I need to say here, if I say angle PRQ, then I need to say angle TRS. Okay, so notice these two triangles, it's not like it's a reflection of each other. It's actually a rotation. It's actually it's like if I took P and drug it all the way over here. Okay, P and T are corresponding. Okay, so these angles are congruent, and then our reason for this, okay, remember, we just said this. We said that these are vertical angles. So this is what we call the vertical angles theorem. Or in other words, just to keep it simple, we'll just say VAT. Okay, the vertical angles theorem. And now I've answered those 2 questions. What do I know for my given, and what do I know for my diagram? And like I've said before, once you answer those 2 questions, you're almost always done. You almost always have enough information to match one of your theorems here. So by looking at this picture, I do have enough information, so I can go ahead and say what I was trying to prove. Triangle PRQ is congruent to triangle TRS, and I'm careful about how I order those letters. I'm just copying that down from the proof statement. And then what is my reason that goes with this? Well, if I look at this picture here, I have 2 pairs of sides that I've said are congruent, and then I have the angles in between them. So in this case, that would be side, angle, side. So side, angle, side theorem here. And like I mentioned, that angle has to be in between them, otherwise it wouldn't work. Okay? These are the kinds of proofs that we're going to be doing in this unit. Can we get our picture to match one of the theorems that we've talked about? Okay? All right, we have that here. And then one more example, not a proof, but just talking through this here. If you'd like to, you can go ahead and sketch these 2 shapes here. But the example or the problem is this. It's saying from these triangles, I want to determine if I have enough information to say that they're congruent. And then if that's the case, then I want to say which theorem that would be. So if I'm looking at my first picture here, I see these 2 triangles here, MLN and PLN, and I want to determine if I have enough information to say that they are congruent. Well, if I'm looking at this here, I have 2 pairs of sides that I'm already told are congruent. So I see those are marked there. And then the question is there anything else we know just by looking at it that would match one of our theorems? Well, notice here we saw the same idea in our first proof. I have a shared side that's in both of the triangles. If I have a shared side that's in both the triangles, I know it's always going to be congruent to itself. So I do actually have a third side that is congruent, even though it's not marked for us. So the question is, do I have enough information to say that these are congruent? Yes, this does match one of the 2 theorems that we talked about today. And which theorem would this be? Well, it's all 3 sets of sides, so this matches the side, side, side theorem. Okay, this is a good skill that you need to learn as you're looking at pictures. You need to be able to look at them and say, which theorem does this match here? Because we are always going to have to do that at the end of our proofs. Okay, so we have the first one done, and now we're looking at this box here, I guess, QRST, with these 2 different triangles, one on the top left and then one on the bottom right. And it's asking the same question, do I have enough information to prove that these are congruent? Well, notice none of the sides are marked for me, so even though they might look like they're the same, or look like they're congruent, I can't necessarily say that. The only thing that I know is that RT is in both of them. Again, that shared side, so I know that's at least one side. But since I don't have anything else, it's asking, do I have enough information? I do not. Okay, I'm going to say not enough information here. Okay, I would need to have some other pairs of sides or some other pair of angles to help me out here. Okay, so this is, again, a skill that you want to get down. But in general, those are the 2 theorems that you can be looking for, and we're going to have some proofs that we kind of work through with that. Okay, so the assignment for this lesson is 6.2, homework, side, 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 and side, angle, side. And as always, if you guys have any questions, feel free to let me know. All right, thanks, guys.